When we're dealing with categorical data that has two different factors, we're going to be using a test for independence as opposed to just a regular goodness of fit test. So what's going to happen is we're going to have contingency tables that will have one factor as the rows and one factor that will represent the columns. Our null hypothesis will be that whatever the variable in the row is and whatever the variable in the column will be independent of each other. And the alternative is that they're dependent. Now, you're going to put these in context, and you won't just say row variable and column variable. You'll say, gender by, I think, responses is what I've got coming up. So you'll see how that works in just a minute. Now, the technology step is our only real step here. It's only going to be done on the calculator. Both TI-83s and TI-84s have a matrix function and the actual chi-squared test in the stat tests area. And this test will give you a p-value. I'm not going to go over the traditional method. It works just like the goodness of fit test. We've got a chi-squared distribution, a chi-squared alpha, and whatever our test statistic is, and it'll be right-tailed. But what we'll be using is the p-value, which will be generated by our test, and it works the same as it always has. If the p-value is less than alpha, we reject. So if we have a small p-value, the two factors are dependent. If we have a large p-value, the two factors are independent of each other. So here we have two different factors. One factor is gender, my row factor, men and women is gender. And the column factor would be, if you could have only one of the following, which would you pick, money, health, or love? So this is the response given by each of our men and each of our women. So at a level 0.05 level of significance, we're going to try to test to see if gender and their response are independent of each other. So basically, if men feel about the same way as women do, or if they don't. So our null is that the response and gender are independent of each other, and the alternative is that they're dependent. And again, alpha is 0.05. Now, what's going to happen is you're going to enter the data into a matrix. What you're going to enter are the observed counts, which I have on top here. The parenthetical values are the expected counts. Now, how you would calculate that without using matrix is, say you wanted the expected counts of men who said that money was what they wanted. You would take the number of men, the total number of men, that 883, and multiply it by the total number who said money, which looks to be 128. And then you would divide it by whatever n is, the 883 plus 893. And that's where this 63.64 will come from. However, our matrices, when we run the chi-squared test, it's going to populate our B matrix and give us these values. And I'll show you how that works right now. All right. Now, on both 83s and 84s, you've got this matrix button. It's the second function. You notice it's in blue for mine, and my second key is blue. So we're going to hit the second button and this X inverse thing. So we need to go over to Edit. And notice I don't have anything in my B matrix. My B matrix won't be populated until I run the chi-squared test. So I'm going to hit enter. I've already got it set up as a 2 by 3. 2 is the number of rows. We have 2 rows. And 3 is the number of columns. We have 3 columns. And I've already got the matrix entered in. So if you notice each of these, this looks like the same contingency table that we started with, 82, 446, 355, and then 46, 574, and 273. So that's what you need to enter into your calculator. Now, running the test. It's going to be in the same area that all the other tests are. We're going to hit Stat, and then go over to Tests, arrow over to Tests. Now I'm going to go up because it's near the bottom. It's C on mine. It'll be a different letter on the TI-83s, I believe. But it's just the chi-squared test. It's not the GOF. The GOF is simply for one factor. The chi-squared test runs 2 factors. So we hit enter. Now, We entered it into matrix A. You can change these if you want, but I would suggest you just leave them at A and B and don't mess with them at all. And you just have to go down to calculate. So our observed values are in A. The calculator is going to put the expected values into B and then calculate the test statistic and p-value. So there we have it. We have the test statistic is 36.84ish, and our p-value is extremely small, a decimal, 7 zeros, and a 1. So certainly less than our 0.05. The degrees of freedom are calculated as the number of rows minus 1 multiplied by the number of columns minus 1. So 2 minus 1 is 1, and then 3 minus 1 is 2. 1 times 2 is 2. But again, it calculates it for you. So that's our information. This is how the test statistic is actually calculated. It's just the same sort of manner that our goodness of fit chi-squared was calculated. We take each observed value, subtract it from its corresponding expected value, square whatever that number is, and divide by our expected value. And we sum these all up. This is just 3 of them. There should be a total of 6, but you see how it kind of goes. And 36.84 is what that comes out to. And there's our p-value, extremely small. That's less than our 0.05, which is alpha, so we reject. So we believe that gender and responses are certainly dependent upon each other.